my dear students. Today I am here to deliver a lecture on electrostatics. Already we have done one lecture of electrostatics. It is covering 10 plus 2, being 12th class syllabus in India, CBSE standard. So we have already done electric charges, conservation of electric charge, quantization of electric charge, and what are positive and negative charges, how they are related to each other. Each and everything about charges we have done already in a lecture which has been already posted in my YouTube channel. If you want to watch that, you can watch in electrostatic series chapter. So today is second topic of electrostatics which we will study, and that topic is Coulomb's law in electrostatics. Before going for Coulomb's law in electrostatic, we will take one another law which is a mechanical law basically, and that law is known as Newton's universal law of gravitation. You might have heard this law in your ninth standard, right? There is a video on this Newton's universal law of gravitation in my YouTube channel. You can also watch that. This Newton gravitation law states that if there are two bodies like you and some other body, your sister, your mother, or even two bodies like two tables, you and your camera, you and your mobile, these are also two bodies, then according to this law, there is a force of attraction between these two bodies. And that force is given by capital G, which is universal gravitation constant. Mass of first body mean u, mass of second body mean the body which we are talking about, which is near to you, and divided by distance between these two and whole square. So this is the force between two bodies, and this is known as universal law of gravitation. In the similar case in electrostatics, this Coulomb laws exist. And what does this tell us? This law simply tells us if there are 2 point charges, right? Say Q1 and Q2, right? And these are separated by a distance small r, right? Very simple. Now a question will arise in your mind. What is a point charge? Very simple. Point charge means a charge whose dimension is such that it is very small in comparison to the distance between them. So if the distance between them is too large, they will be considered as point charge, right? So if Q1 and Q2 are the point charges, then according to this law, there will be a force of attraction or force of repulsion. This is electrostatic attraction and electrostatic repulsion. Now, what is electrostatic attraction and what is electrostatic repulsion? In the lecture charges, I told you very clearly that there are two types of charges, positive and negative. If these two charges, Q1 and Q2, both are positive, then there will be a electrostatic repulsion between them. They will repel each other. Okay? And if these two charges are negative, both are negative, then again there will be a electrostatic repulsion. They will repel each other, right? And if these two charges are unlike, like one is positive, other is negative, then there will be a force of electrostatic attraction between them. Positive and negative attract each other, right? So let us suppose these Q1 and Q2 for time being are both positive charges. Because we are positive people, let us take positive charges only. So when we talk about positive charges, Q1 is also positive, Q2 is positive, so there is a force of electrostatic repulsion. Means charges will exert force on each other and there will be a repulsion. These will fall apart. The force exerted by Q1 on Q2 will make this Q2 go away, and the force exerted by Q2 on Q1 will make this Q1 go away. So there will be a force of repulsion between these two. Let us assume that Q2 exerts the force on Q1. Okay, and that force is naturally F12. F12. What is F12? F12 is the force on charge number 1 by the charge number 2. This is a simple notation, method of writing, so that we can understand the things easily. Nothing complex. Don't get scared by this, that F12, what is this Q1? This is simple notation, by which we denote something. Like we are denoting that F is the force. I told you there is a force of repulsion. Now Q1 will exert force on Q2. Q2 will exert force on Q1. And what is F12? Force on 1 means Q1 due to 2, right? And it will be towards this direction. So it will be towards this, right? Now Q1 will exert force on Q2. So it will be along this direction, because it will attract, it will not attract, it will repel this charge. If it will repel, it will go like this. So the force will be F21. F21 mean force on 2 mean Q2 by 1 mean Q1. Simple. What is F12? Force on 1 mean charge number 1 Q1 by the charge number 2 mean Q2. And what is F21? Force on 2 mean Q2 charge by the charge Q1. Right? Very simple. Okay. Because we are taking vector form also, that's why I told you this. Okay. In general, there is a force of repulsion between Q1 and Q2, right? This is simple, nothing complex. So let us make it simple. According to Coulomb's law, the force of attraction, whether F12 or F21, generally we take one force, say F. So that F, mean force of repulsion between these two charges, is directly proportional to product of charges. We are not taking vector or scalar sign, right? It's normal without vector sign, magnitude only. So force is proportional to Q1 and Q2. Do you remember in Newton's law of gravitation, universal gravitation, we told you that F is proportional to product of masses. Similarly, here force is proportional to product of charges. Now in place of masses, we have electric charge. So, and what does this statement show? This statement shows that more will be the charge amount of charge, more will be their product, and more will be the force between them. Natural. It's natural. Naturally, IQ based question. If there is less charge, suppose it is 2 Coulomb, it is 2 Coulomb. Coulomb is the unit of charge. You know that from the previous classes. So it is 2 Coulomb, it is 2 Coulomb or 3 Coulomb. The force is, say, 5 Newton, let us suppose. And let us say this is 1000 Coulomb, this is 2000 Coulomb or 1000 Coulomb. Then the force will increase automatically because of charge value. Because according to this law, force is directly proportional to, mean if these quantity will increase, this force will increase, right? What is this force? Force of repulsion. Equation number 1. You will be surprising why we are not using F12, F21. F12, F21, I told you just because we have another topic which is vector form of Coulomb's law. Then we will take this. You know vectors, you have studied in your 11th class, very simple. Otherwise, I will tell you each and everything about vectors here also, whatever is needed, right? Don't worry about the vectors. We have taken general force, that general force between Q1 and Q2 is, say, F. We don't take F12 and F21, right? We take some resultant force. Okay, and that resultant force is proportional to Q1 and Q2. Another thing Coulomb's law says that this force is also inversely proportional to square of the distance between them. Same in Newton's universal law. F was proportional to 1 upon r square. Inversely proportional mean if r increases mean the charges are separated distance apart, then it is in denominator. If denominator increases, total value decreases. There is a law. So F will be less. Naturally, if the things are the charges, which we are specifying here, charges are placed far apart, the force of attraction or repulsion between them will be very less naturally. And if they are close together, mean R is now decreased. R is in denominator. If denominator decreases, whole thing increases. You know that. Look at this. 10 upon 100, 10 upon 1000, and 10 upon 10,000. Which will be less? This will be less. Because more is the denominator, smaller is the value. Simple concept, you know from 7th or 8th class. So if R will decrease, mean charges are now together, nearby. This R will become less. If R is less, force will be more. Naturally, the charges are very near to each other. Then the force between them will be more. This is according to Coulomb's law. Now, we just combine these two. So F proportional to Q1, Q2 upon R square, right? If we remove this sign, we put equals to, and in this we took in Newton's law gravitation capital G as a constant. Here we will take capital K as a constant. Q1, Q2 upon R square. This is nothing but Coulomb's law in electrostatics. So Coulomb's law gives us the magnitude of force which is either attractive force or electrostatic repulsive force between any two point charges. I am always emphasizing the word point charges. Remember, Coulomb law is valid for point charges only. Remember this point, right? So F is the force of attraction or repulsion depending upon the polarity of charges, whether these are positive, 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 negative, or negative, negative. I told you earlier. Then this force will be equal to K times Q1, Q2 upon R square. What is K called as? K is equal to 1 by 4 pi epsilon 0. 1 by 4 pi epsilon 0. What is epsilon 0? This is permittivity of free space. Free space means vacuum. Okay. So its value is 8.85 10 to the power minus 12. Okay. So when you put this value of pi, value of 4, the value of K nearly comes out to be 9 into 10 to the power 9 Newton meter square per Coulomb square. This is the value of K. Like there, the value of G was in Newton's universal law of gravitation 6.67 10 to the power minus 11 Newton meter square per kilogram square. Kilogram, why there was kilogram square? Because we are dealing with mass. Here we are dealing with charges. What unit of charge? Coulomb. So that's why in denominator unit is Coulomb square. So it's very simple to memorize these things if you know the foundation of each and everything. That Newton universal law of gravitation is for masses, point masses. And this Coulomb's law in electrostatic is for point charges. So there is a similarity. It is an analog in electronics. Like it is mechanical analog. So force is given by K Q1 Q2 upon R square. This K is called electrostatic constant. Electrostatic constant. So what is Coulomb's law? Let me state this Coulomb law. Now you don't have to cram actually, just understand. Coulomb's law in electrostatic states that the force of electrostatic force, okay, electrostatic force of attraction or repulsion between any two point charges is directly proportional to product of charges and inversely proportional to square of the distance between these charges. So simple to understand, so simple to write this definition if you know the basic mathematics. I didn't cram this. I took this definition from this diagram and this. So again, I'm repeating for you. that according to Coulomb's law in electrostatics, the electrostatic force of attraction, either it is force of attraction. When it will be force of attraction? When these two charges are unlike, like positive and negative. Then it will be electrostatic force of attraction. And this is same, plus plus or minus minus. Then there will be repulsion. So according to Coulomb's law in electrostatics, the electrostatic force of attraction or repulsion is directly proportional to product of charges and is inversely proportional to square of the distance between these charges. What is difficult in this? Nothing. So this is a statement of Coulomb's law, right? So what do we get from Coulomb's law? What actually Coulomb's law gives us? This. What is this? Electrostatic force of attraction or repulsion. So using this Coulomb's law in electrostatics, we can define 1 coulomb of charge. What is 1 coulomb of charge? Let us put Q1 equals to Q2 equal to 1 coulomb, right? Then R equals to 1 meter. Then F will be equals to K, right? Because these are 1, 1, 1, so F equals to K. Or F equals to, what is K? 1 by 4 pi epsilon 0. Or what is this value? 9 into 10 to the power 9 Newton meter square per coulomb square. So we can simply define 1 coulomb of charge, that 1 coulomb of charge is produced, so we can define that the 1 coulomb of charge is that much charge which can produce force of attraction or repulsion between them equals to 9 into 10 to the power 9 Newton meter square per coulomb square, provided these charges are kept in vacuum 1 meter apart. This is a simple definition, right? Again, I am repeating that charges are said to be 1 coulomb if the force of electrostatic attraction or repulsion between them is equal to K. What is K? K is 1 by 4 by epsilon 0, and what its value? 9 10 to the power 9 Newton meter square per coulomb square. Electrostatic force constant. So we will define that charges are said to be 1 coulomb if the electrostatic force of attraction or repulsion between them is equal to 9 into 10 to the power 9 Newton meter square per coulomb square, provided the distance between them is 1 meter and they are kept in vacuum. Very simple definition. Okay,